The introductory sequence you've just seen was a compilation of HAL work from customers around the world. It demonstrated the range of different applications HAL is able to undertake, such as title sequences, promos, stings, commercials, and corporate work. This training tape is designed to show you the operating techniques used in the production of such sequences. The tape is composed of several sections, each covering a different functional aspect of HAL. It's assumed that you're already fully aware of the V-Series paintbox. The 2 additional tapes cover paintbox operation, should you not be familiar with it. The reference manual should be used in conjunction with this tape to provide additional detailed information on each function. Before looking at the operation of HAL, it's worth spending a few moments taking an overview of the system. HAL is designed to be a complete compositing environment for the creative assembly of moving images. It makes use of paintbox techniques and has full paintbox facilities, but is intended to work with moving images. It has an integral keyer and processes multiple layers. The video material is held on special random access disks, which make use of Quantel's chatter disk management to provide a desk workspace for the designer. All the required facilities are integrated into a single unit which uses Quantel's familiar tablet and pen user interface. As a design and post-production tool, it's intended for use by designers with either a graphic or editing background. Section 1. Vtr Control and recording material into HAL. We'll start by looking at Vtr Control from the tablet and recording material into the system. Selecting clips, we gain access to the clip desk, which is currently empty. The Record menu offers 3 source options: VTR, analog, or one of the 3 digital inputs. The VTR input is configured from the full-page menu. The VTR menu displays the transport controls and timecode reference boxes. Using the pen, the transport commands can be executed. The arrows enable the VTR to single-frame step. By selecting the shuttle bar from the middle of the menu, the VTR will drop into shuttle mode. The shuttle speed is determined by the length of the shuttle bar. Moving the pen beyond the end of the shuttle bar will force the VTR into fast forward or reverse. Pressing down on the screen will put the VTR into jog mode. Moving the pen in a circular motion will jog the VTR. The faster the movement, the faster the jog. Clockwise movement will jog forward, anti-clockwise will jog backwards. The timecode readout from the VTR is displayed in the blue box to the left of the transport commands. A specific timecode can be entered via the keypad. The 2 green timecode boxes set the in and out points for the transfer. The tape timecode from the blue box can be entered by selecting in or out. Alternatively, highlighting the green box allows direct timecode entry from the keypad. Once the out point has been set, the blue duration box displays the length of the selected clip in frames. The cue boxes will cue the VTR to the timecode. Pressing Do Clip will initiate the auto-edit command to the VTR, and the video clip will be recorded onto the disk store. After transferring the clip, the blue box will display Clip 1, indicating 1 clip has been loaded. Subsequent transfers will increment the count. Clear resets the counter. With a VTR in play, it's possible to crash record onto the disk store. Selecting Crash initiates the recording. Pressing the pen down stops the recording. Selecting Audio will record the clip with its associated audio, which is referred to as clip audio. A background audio track can be recorded in by selecting both audio and background. The video will be seen during the transfer, but not recorded onto the disk store. This, as we will see in a moment, can be used as a guide track for video editing. We've now recorded in 2 video clips, one without audio, one with, and a background audio track. Before looking at these clips on the clip desk, we'll take a brief look at recording from other sources. With VTR deselected, we have the options of many, single, or continuous. Many enables a set number of frames to be recorded by entering a numeric value in the green box. Single records a single frame, which can be useful for grabbing images from a live video input, such as a copy camera. Continuous will record a clip under manual control. All of these record functions are initiated by tapping down the pen or pressing button number 1 on the rat. In the case of a continuous record, a second tap will stop the recording. If the Add box is enabled, then the subsequent recorded clip will be added to the current selected clip. The source input can be selected from Analog, Digital A, Digital B, or Digital C. If none of these are selected, the last image on the screen will be recorded. This provides a quick method of recording a graphic image created with Paint and Graphics, or an image from the library. We now look at the operation of the clip desk. Section 2. The clip desk and clip editing. The clips menu under Animation is referred to as the clip desk. This is where the clips stored on the video discs are accessed. The lower bar holds the selected clips. Tapping down over the clips selects them as the current clip. The orange shuttle bar can be used to shuttle through the clips. The upper bar is the selected clip's control bar. As before, the orange bar can be used to shuttle through the clip. The length of the clip on the lower bar is proportional to the overall menu length. Additional clips will be recorded onto the desk at the right-hand side. The clips will be squashed to fit along the bar. The upper bar will always be the full length of the menu. The arrows control the position and playout of the clips. The first arrow will step to the first frame of the clip. A second press will step to the beginning of the previous clip. In a similar way, the second arrow will step to the end of clips. The second and third arrows will single step through the clip backwards or forwards. Holding the pen down instead of tapping will repeatedly step the clip. The next pair of double arrow boxes will play the clip forwards or backwards, stopping at the end or beginning of the clip. Once pressed, the menu can be swiped off. The final double arrow box will play the desk out. Again, the menu can be swiped off. The 3 numeric boxes indicate the following: the current frame of the clip, the overall length of the clip, and the number of free frames left on the video discs. Entering a number into the frame count box will step the shuttle bar to this frame. The shuttle bar can also be moved by scrolling the pen on screen while the box is enabled. This gives finer control on longer clips. Pressing the clip length box will display a timecode notation instead of a frame count. This is only a notation display and has no reference to the source timecode of the clips. Pressing the free frame box will dump the unused frames onto the desk as a single clip. These frames will contain all the frames that have been deleted from the desk and the frames from clips in the clip library, which we'll cover later. This function can be useful in recovering clips that have been accidentally deleted, though the clip may be fragmented due to the random access storage of the disks. It's therefore a last chance mechanism and should not be used as a normal operational procedure. The audio and background boxes indicate the presence of audio. As you can see, there's a background track and one clip has clip audio. The audio tracks can be heard by enabling these boxes. With audio enabled, a byte of audio is heard when selecting a frame off the desk. The frame duration of this byte is set with byte size, and the direction of the byte, that is, after the frame or before, is set with the direction arrow. The order of the clips can be changed by moving them on the desk. Selected clips can be moved before or after other clips on the desk. Clips can be edited with Snip and Delete. A snip can be made before or after the current frame. The original clip is now split into two separate clips. Clips can be deleted from either the top control bar or the bottom. To prevent accidental deletion, it's always best to select the clip first and then delete it from the top bar. The top bar can also be used to trim the ends of a clip to produce tails, frames of the clip that are not used but are still present on the discs. By selecting the end of a clip and applying pressure, the pen is moved to pull a tail. The light grey portion indicates the active frames of the clip, while the dark grey indicates the unused frames. If a clip has clip audio associated with it, the audio will be snipped with a video and be mute within the tails. The boundary between clips is referred to as an edit event. Snippets give a very clear display of the edit event. The snippet frames are very much like the browse images in the library. Once they've been displayed, they're quickly available again, as we shall see. The middle snippet frame is the current frame position, which is the full frame display. The snippets to the right display subsequent frames, while those to the left display previous ones. Pressing on the snippets enables them to be scrolled. They're pressure sensitive. The more pressure, the faster they scroll. A swift movement of the pen will position the display at the ends of the clip. The snippet display can be used with the snip and delete functions. Here, for example, deleting the last two frames of a clip. To produce a dissolve between two clips, we first need to pull tails. Using Splice, we have access to both clips at the edit event. The upper bar splits in two, representing the two clips. Using two clips, we'll pull 10 frame tails on each and enter 10 frames into the duration box. The system will generate 10 new frames to make the dissolve, which we can then preview. The dissolve is uncommitted at this stage. Its duration can be changed. The start and finish positions are also uncommitted. By trimming, they can be repositioned. When this is done in conjunction with an audio backing track, It enables edit events to be synchronized with the audio. Each transition between clips on the desk can have its own uncommitted edit event. These can be reviewed along with the background audio track by playing out the desk with the menu swiped off. When all the edit events have been adjusted, the clips can be joined together to produce a single clip. This can be used as the background for a multi-layer sequence, as we shall see later. Section 3. Clip Library. At this point, we should introduce the function of Clip Library. The video clips are stored on the video discs. Initially, they are recorded onto the desk. They can be removed from the desk and filed in the Clip Library. In the Library menu, there are clips as a type. The library stores an index reference to the location of the clip on the video discs. The library entry has all the usual parameters. Entries have a title, a file card, and a browse image. The middle frame of the clip is used as the reference image. The titles also display the timecode duration of the clips. Operationally, the desk is cleared with Delete All Clips. The clip library is then used to find the required clips and load them onto the desk. Clips are saved to the clip library in a similar way. It's worth noting that the clip library stores all the parameters of a clip, such as its tails, audio, and other attributes, which we shall cover in a moment. Calling a clip to the desk twice will not use any extra disk space. The frames are simply read twice. Likewise, a new clip that is made from a combination of clips already in the library will not take any extra space. Only the new frames produced in, say, a dissolve will take up space. Section 4. Rotoscoping. Rotoscoping is a very simple task within HAL. The rotoscope version of the clip is presented as a new version of the old clip on the desk. Having selected the first frame to rotoscope, we can move into Painting and rotoscope the frame. Pressing button number 1 on the rat will perform a Next function. The rotoscoped frame will be sold back to the desk and the next frame brought into the painting buffer. Subsequent Next functions will repeat the process, selling painted frames and buying the next frames. We'll rotoscope several more frames, including a deliberate mistake. Pressing button number 3 on the rat will display the previous frame for reference. Swiping the menu on we can see a frame count on the current frame in the clip. Pressing this box will display the rat button functions in rotoscoping. Pressing the Quantel HAL box will display the current software version. Back on the desk, two boxes have appeared, old and new. The old is the original clip. The new clip is made by combining the rotoscoped frames into the original clip. Only the rotoscoped frames are saved. The random access of the discs is used to call them up when required. The old frames still exist, and this allows us to replace frames, as with this mistake. Playout allows the clip to be viewed in a loop mode, in reverse or in bounce. These modes can be combined. For example, a looped bounce. The number 1 and number 2 boxes on the desk refer to field 1 and field 2 of the selected frame. If the clip is to be rotoscoped in fields instead of frames, select field number 1 before going into painting. Pressing Next now will buy and sell in fields. When selling frames or fields, they can go into this clip or a new clip. If a new clip is chosen, subsequent frames will be sold after the first frame. The rat buttons are mimicked on the desk. It's possible to use a static stencil to rotoscope through, and as we'll see later, key signals associated with the clip can also be rotoscoped as clip stencils. Section 5. Multi-layering and keyframe effects. Using paintbox techniques, it's possible to cut multiple cutouts and paste them over a background. The difference with HAL is the cutouts and the background can be moving video clips. In the Cut menu, we have the option to cut clips and set a background from the desk. After selecting a clip, we can define the area to be cut. In this case, we'll cut out a layer from 4 different clips. These could be cut with a grid if required. Swiping on the menu and wiping the background, we see we have 4 cutouts or layers. The layers have reset to show the first frame of the clip. Using the Only box, it's possible to restrict control to the numbered layer, in this case number 4. By changing the number, the other layers can be controlled. Disabling the Only box allows the required layer to be selected off the screen. As the pen passes over the layer, it turns pink. Tapping down selects that layer for manipulation. We can examine the relative layer priorities. Layer number 4 is the one closest to us, while number 1 is furthest away. To change the layer priority, enter the required layer number into the box. Under the Style menu, there's a Use Fields box. This is used to set the layer as a field-sourced material, such as video, as opposed to frame-based material, such as film. Subsequent cutouts will take the field setting of the previous layer. Each of the layers can be manipulated using the 3D Paste menu to set position, spin, size, and opacity. The layer can also have a graphic style assigned to it. The Copy function will make a copy of the selected layer. A keyframe move can be made by setting keyframes for each layer. For simplicity, we'll create a move for 2 layers, though in practice there can be any number up to 99. Selecting Delete and tapping on the cutout will delete this layer. So here we'll delete layers 4 and 5. Layer 3 may have been moved off screen, and so we cannot select it. To regain control of this layer, we need to select Only and enter the layer number, in this case 3. Now we can bring the layer back into view and delete it. Delete Cut will delete all the layers. Selecting Keyframe gives us access to a keyframe timeline. Keyframes can be entered onto the line manually or automatically. We'll set up the first layer with Manual Edit and the second layer with Automatic Edit. First we need to set the keyframe duration, say 50 frames. If we'd selected a background clip before entering keyframes, the duration would have been set to the background length. Moving the timeline, we can see the layer updating and the frame count incrementing. As soon as a change is made to the layer, the edit prompt appears. The new keyframe is not entered onto the timeline until we confirm it by pressing the Edit box. When the keyframe is confirmed, a white notch appears on the timeline, and if selected under the Artist menu, stripy string is displayed when the cursor is in proximity. Stripy string displays the motion path of the layer, and each division represents 1 frame's duration. The layer can be viewed at any point on the stripy string and modified as desired. The move defaults to a profiled motion, which can be changed to a linear motion into and out of the keyframe, or have a stop motion. The arrows can be used to step through the keyframes. Try It will preview the move in low resolution. The second layer will now be set up in the Auto mode and will include opacity changes. By enabling the frame count box, it's possible to change the time at which the keyframe occurs. It's also possible to trim the start point of the layers on the desk. Everything is uncommitted at this stage. Layers can be added, deleted, priorities changed, or positions changed. So far, we've set the move up over a black background. We can now choose to have a moving background. Again, we can still slip the background relative to the layers. Once the move has been set up, it's processed in either frames or fields with the Do It box. it's possible to stop the processing at any point and change the layer priority. Processing will continue from this point. On the desk, there's the finished version in the new clip and the original background in the old clip. The move is retained in the Paste Up menu, and the keyframe can be saved to the library for future use. Section 6. Keying. The keyer allocates stencil to the area of picture to be keyed out, typically the blue of a blue screen shot. Having processed the stencil for each frame of the clip will now have a clip stencil attached to it. This clip stencil acts as the key signal when the clip is cut with its clip stencil. The selected clip from the desk is available on a control bar in the Effects menu. Before looking at how to key a blue screen shot, we'll take a brief look at the principles of the keyer. The keyer operates on luminance and chrominance information. A key can be generated from either or a combination of both. This graphic shows a range of luminance and chrominance values. First, we'll select only a luminance key. By tapping down, we select a particular value of luminance to which we allocate stencil. The graphic display in the menu shows this. Selecting chrominance only, we can again see the selection. All colours contain both luminance and chrominance, and to be precise, we may need to combine the luminance and chrominance values. As we can see here, a combination key will produce a very accurate defined area of keying. The selected area adds to the keying range. The Values box allows us to vary the key signal very precisely. The three vertical columns refer to Y, U and V, the luminance and colour difference components. The low and high boxes indicate the numeric keying range. With the pen in proximity, the values under the pen are displayed. By comparing the low and high values with the pen values, it can be seen which value needs adjusting to include the pen area. Softness will change the slope of the key signal from a hard on-off signal to a linear one. It's possible to alter the softness of the luminance and chrominance components individually. Having looked at the theory of the keyer, we'll now see how to use it in practice on a typical blue screen shot. Using a combination luminance and chrominance key, we can select the blue from the shot. As we select more of the blue area, the stencil builds up. Using zoom, we can examine areas in detail and pick individual pixels. Moving through the clip, we can check the key signal is holding for the whole clip. The lighting may change during the shot, for example. Having set a basic key, we can examine it in high contrast and see its effect over a background by selecting Draw Stencil. Adding softness to the whole key or individually under Values will produce a linear key. The display shows a matte signal while softness is set. At this stage, the key can be processed for the whole clip. The key settings will be applied to each frame of the clip to produce a stencil for each frame, a clip stencil. The key signal produced will probably require further treatment before it's used to separate the foreground. the clip stencil can be blurred to produce a soft edge. With Draw Stencil selected, the clip stencil is displayed. The blur function has a square preview area centered on the cursor. Pressing and scrolling the pen will set the value while displaying the result in the preview area. Do All will process the blur over the selected frame. This will replace the existing stencil. The result can now be seen in high contrast and over grey. Blur can be applied to the whole clip with Do Clip. The resulting key will be soft but still has blue fringing. This can be dealt with the Grow function. The edges of the clip stencil can be expanded or contracted to deal with blue spill or to produce a soft drop shadow effect. Grow functions very much like Blur with a preview window, and Do Clip applies the grow to the whole clip. Having processed the required clip stencil, the clip can be cut, this time with its clip stencil, and keyed over a background in Paste Up. A degree of experimentation will often produce the best key. For example, it may be better to grow the clip stencil first and then blur it. Likewise, a little time spent working with values may provide the solution to a difficult key. There are many ways to use the keyer, and time spent exploring possibilities will improve your results. If Draw Stencil is not selected with Blur, the clip itself can be blurred, that is, defocused. This can be used to give us a fixed amount of defocus to produce layers with depth, or with Sequence can produce pull focus effects. Section 7. Color Correction. The luminance, saturation and hue parameters of a clip can all be changed within the color corrector. Negative values can be entered for certain parameters. For example, minus 100% contrast and 200% brightness will invert the luminance. As with the keyer, the effect can be applied to a frame or the whole clip. The Sequence function can also be used to produce custom effects, such as a profiled desaturation of the clip. The correction can be applied through a stencil to provide selective color correction. The stencil can be a static graphic one or the clip stencil of the clip. Additionally, the basic key setup from the keyer, that is, luminance and chrominance values with softness, can be used directly in the color corrector without having to process it for the whole clip. This can be very useful when using a reverse key stencil to colour correct the background before pulling the cutting key, as we do here to colour correct the blue to a sympathetic foreground colour. Later we'll see how the key from the blue screen shot can be transferred to this colour-corrected shot. The result is a key shot with a colour-corrected blue fringe. We'll now return to the clip desk and look at the copy functions. Section 8. Copy functions on the clip desk. The copy functions are split into two groups, those that are creative in nature and those that provide operational functions. We'll look first at the creative ones: stretch, average, integrate and reverse. All the copy functions allow the same general structure. A clip is selected to copy from, which then turns blue. The copy function is then selected and any required parameters entered. Then the destination on the desk is selected for the copied version. To start, we'll take the case of stretch, which will increase or reduce the length of a clip in fields or frames by generating the required number of new frames. Selecting the clip to copy from, we can enter the new duration and select either a frame or field-based stretch. The copied clip will be made after the chosen clip on the desk. Average, integrate and reverse all work in the same way. Average will produce a clip of the same length with frames made of the average of adjacent frames. This results in a motion blurring effect. Integrate will use all the frames of the clip to produce a condensed clip. Along with speed effects, this can be used to reduce noise on still frames. Reverse copies the clip in reverse. With field mode, it reverses the field order for smooth motion. Deinterlace will produce frames from fields. That is, field 1 is repeated to produce frame 1. Field 2 is repeated to produce frame 2. Interlace will reverse the process. Invert Dominance will correct a clip on the desk which has been recorded with the wrong dominance. It does this by deleting the first and last fields of the clip. It should be noted that the system should work completely in field 1 or field 2 dominance. That is, the material on the desk should be of the same dominance as the system. System dominance is set from the full page menu. Cine Compress enables the 3-2 pull-down sequence used when transferring film to NTSC to be undone, so producing the original film frames. This is especially useful for retouch or rotoscoping work. Cine Expand will apply the 3-2 sequence to the clip. To Cine Compress a clip, it's first necessary to identify where the first frame is in the still, flicker, flicker, still, still sequence. These are indicated by the boxes. Having established which the first frame is, the appropriate box is highlighted and the copy performed. Obviously, the second flicker frame is artificial and so cannot be used as the first frame. The Cine Expand sequence will always produce the still, flicker, flicker, still, still sequence in the resultant clip. Should the material need to be replaced into the original footage, it should be brought onto the desk as a still, flicker, flicker, still, still clip. The remaining copy functions are concerned with transferring attributes of one clip to another. For example, copying a black and white matte directly to the clip stencil of a clip, or copying audio tracks between clips. A matte can be assigned to the clip stencil. In this case, it's the 3D matte of a 3D ball, both of which were rendered by a 3D system. Conversely, a clip stencil can be copied out to a matte. This enables the matte to be treated as video, perhaps to add a tracking garbage matte in paste-up, though, as we'll see, there are other ways of modifying the clip stencil. The clip stencil of one clip can be copied to the clip stencil of another. A copy of the clip itself can be made. This will be required if the background is to be the same as the foreground layer. the system will not allow one clip to be used for both the foreground and the background. Clip audio can be copied from one clip to another. The background audio can be copied into the clip audio of a clip. This enables a finished background sequence to be saved in the clip library with its audio. The background audio remains on the desk, allowing different video or versions to be cut to the track. Section 9. Clip Stencils. Having covered the production of clip stencils, we'll now take a brief look at some of their applications. To view a clip stencil on the desk, we can enable Draw Stencil. As the clip is moved, the stencil can be seen. Alternatively, if a quick check is required, the blue Sten box can be pressed and the stencil will be displayed, leaving the Draw Stencil buffer unchanged. In the section on rotoscoping, we mentioned the ability to rotoscope stencils as well. If Draw Stencil is on when rotoscoping a clip, then it's the clip stencil which is rotoscoped. If a clip stencil exists for a clip, it can be used in Use Stencil when rotoscoping the video. Any stencil which is present in the stencil buffer will be replaced by the current clip stencil. To use a static stencil to rotoscope a clip, the clip stencil should be deleted from the clip. The clip stencil will still exist with the clip in the clip library. When Draw Stencil is on during paste-up processing, the foreground layer will be stamped into the existing clip stencil. This provides a very quick way of adding a tracking garbage mat to a clip stencil. Finally, if the background clip has a clip stencil and the foreground layers have clip stencils, they'll all be active during a process. Section 10. V8 HAL Update. For those of you who are familiar with the graphics section on the V8 Paintbox tape, on entering graphics, the last used shape is displayed on screen as a preview. Providing the menu was on screen, the shape could be edited using either the pen or numeric values. Now, if you swipe the menu off screen, a new shape can be created and confirmed by a press of the pen on the tablet. If the menu is then swiped back onto screen, this new shape can be edited in a similar way. Accurately registered stencils can be achieved by enabling the Draw Stencil box, making any edits required, and confirming by the Stick box. Section 11. Library Operations. In this example, we have a section of video which is 700 frames, or 28 seconds long. That's been trimmed at the beginning by 250 frames, or 10 seconds. We could also trim the end of this clip if required. Part of the material has already been rotoscoped to give a glow on the word Sport, providing us with an old and new version. Together with its associated audio track, the video in its old and new versions can be saved as a clip in the library on the internal disk. Having deleted the clip from the disk, we can return to the library and search the clip just saved. The browse shows us the middle frame of the clip. When taken back to the desk, the clip appears in its original form together with audio and the new rotoscoped frames. Groups of clips can also be saved to the library as a desk. If we create a title flag for this clip and sell it to the end of the desk, we can move it to the start of the material and then save the whole desk to the library. When we search for this desk and browse it, we're shown the last viewed full frame, in this case the title flag. A clip can also be saved with its associated stencil. Here we have some boxes against a blue screen, together with its black and white matte run. Using this matte, we can create a stencil for the clip and then save both to the library to be used later. It's now possible to set up key values and save them in the library. Blur and grow values can be annotated within the descriptive text as required. Color correction values, including posterization, can also be saved in this way. The powerful titling facilities within the file card allow any number of items to be saved or retrieved, either individually or as a group, to give fast, accurate control over materials stored in the library. Section 12. Archiving. Any of the library management procedures you've just seen can be taken one step further with archiving. The video with old and new versions, stencils and tails, together with the clip audio, is laid down to tape while the operator has the choice of where to store the directory information, either on the internal disk or onto a magneto-optical removable cartridge. When a clip is searched in the library, the Archive box appears within the menu. On the top-level menu, you have to enter the tape number, for example, number 1, for your first archive tape, together with the next clip timecode, which is the starting point on the tape for your archive session. This point has to be found and entered from the tape at the beginning of each session. The tape end is the timecode of the last usable frame on your archive cassette. If this timecode is exceeded, the HAL will inform you that there's insufficient space. Clip gap denotes the number of frames between each archived entry. Remember that your archive tape must have contiguous timecode. Having set up the VT information, we're ready to archive the clip. Returning to the library, we select the Archive box, together with the relevant clip. Enable the VTR box, which shows us the present status of the VTR. Choose the disk where we want the directory to be saved, either the internal or the magneto-optical, and confirm the operation. When archiving a disk, any uncommitted dissolves are laid down to tape together with the clips. The old version is laid down first with the clip audio, while the new version, tails, stencils and other video material are laid down in a non-linear format. The directory information on disk allows HAL to reconstitute the disk into its pre-archived state. Background audio cannot be archived, so if required, it must first be copied to a clip of the same length. This clip can then be archived and its audio reloaded as a background audio clip under normal VTR control. To search for archive material, use Arch Clip or Arch Desk. The title display tells us the archive tape number, while the file card also gives us the start timecode and total duration of the archived entry, which is not necessarily the length of the clip. When restoring archived material back onto HAL, it's recorded to the internal disk and brought down to the desk in the normal way. Any background audio has to be recorded straight to the desk by timecode. Section 13. Worked Examples, Split Sessions. The archive function allows split session and job rebuilds to be handled quickly and effectively within the HAL environment. In this example, we have a typical job in progress. On the desk, there are clips with uncommitted dissolves, tails, mats, rotoscope frames, stencils and paintbox stills. To these we'll add an audio clip and the rushes that were saved earlier as a separate desk. Due to reasons such as end-of-session booking or waiting for client approval, the whole job, including colour setups, keyer setups, together with paintbox cutouts, can be archived off as a group, leaving the HAL clear for the next job. Reloading the job simply requires loading the appropriate archive tape and magneto-optical cartridge, if used, and recalling the relevant elements. Section 13. Worked Examples, Job Rebuilds. This is an example that was created on HAL, delivered to the customer, but now needs rebuilding due to some colour correction. All the elements were originally archived to tape and magneto-optical cartridge. To rebuild the job, we can reload all the video and audio material together with the keys, textures, grids and colour setups. Although this is a worked example and an ideal situation, remember to save all the available material you may need for future possible alterations. Once the material has been copied to the internal disk, we can search the library and bring the job down to the desk for rebuilding. If we look at the desk, we have the original blue screen shot of the boxes together with its clip stencil. The soft shadow mat with its stencil, the original silk background, plus a colour-corrected version. And we have an example of the original job. The first part of the job is to colour correct the background. In the library, we have a colour setup that, when taken into effects, converts the silk screen and provides us with a new version. The old version can now be deleted. The boxes need to be replaced over the new background, and in the library there's a grid that will allow us to accurately cut out the boxes together with a palette, giving a colour for the shadow. Having cut out the boxes, we can cut out the shadow with its stencil and give it a colour. We also need to change its priority, so the shadow is behind the foreground. The moving text now has to be colour corrected and keyframed. In the library we have a mat for the text, which is brought down to the desk and overlaid to give a stencil. The texture is also brought down from the library and cut out using another grid. The final cutout is the word "Tonight", and after setting the clip for the background, the keyframes and the mask are brought from the library. The entire effect can be previewed to see the new text with a new background and any required changes made. Finally, processing the clip to give us a finished result that can be played out from the desk. From these two examples, you can see the benefits of being able to access all the archived elements. Not only video, but palettes, stencils, grids, cutouts and keyframes, giving us the freedom to make the changes when required.